What's up, Algebra 2? So I gave you some review problems to kind of think about all the stuff we've been talking about recently. And so I thought I'd film a quick video to kind of talk through some of that stuff with you. Let's be careful with this minus in the middle. That is really important to understand that we're really subtracting everything that's in the second parenthesis. So let's find like terms and connect them and see which ones go together. So we have 7r to the fourth minus 8r to the fourth. Okay, 7 minus 8 is -1, and then you need the r to the fourth to keep it going. So the next one is an r to the third, because I'm trying to put it in standard form where the power counts down as we go, and really there's not another cubic, so that one doesn't change. It doesn't change signs because it's in front of the subtraction sign. So next we have this linear. There's no quadratic, no r squared, so I go to the linear, and that's -3 minus 4, and that's where I get -7 from. And then the last one is what you see this little black line connecting -4 to, and that's why I have at the very end a -4, because it doesn't have any like terms. So this one's a little easier because of the plus. A lot of students do better with plus because it doesn't mess with signs as much as minus will. That's 6x to the fourth plus 6x to the fourth, 12x to the fourth. Next we have a cubic, -5 plus 1, -4. Next we have a quadratic, -7x squared plus in the middle, -2. -7 plus -2, -9, x squared. So that's something we've had on several tests, honestly, and just kind of keeping that an idea so that on the cumulative that we take here in a few weeks, that's something that's easy for everybody. This could be something that we find a little challenging, but hopefully you'll remember us doing this in class. It says write a polynomial function of least degree with an integral coefficient that has the given zeros. So the idea is that if 5 was a 0, then that means one of the factors would have to be x minus 5. If 3i was a 0, then that meant when you were solving, you got something like this at the end. Going backward, the way that you got 3 is that you ended up square rooting a negative, and that number had to have been 9. Well, let's add 9 back over the other side so that we get equal 0, and so this is what that factor would have looked like for you to get a negative or a positive 3i answer. Alright, so looking at this other one, it's very similar. If 2 is a 0, then x minus 2 is a factor. If -7 is a 0, then x plus 7 was a factor. And then similar to what we just kind of talked about, if 3i was a 0, then that meant you really square rooted a -9, and so that meant in the beginning you must have had x squared plus 9. Because again, when you set that equal to 0, you'll minus the 9 over to make it negative on the other side, and then when you square root to solve, it ends up giving you an imaginary 3 or -3. Okay. So I already kind of worked these out at school so that I could kind of talk through us at home. So if you need to pause the video, you can. But basically, when I look at this, I'm trying to see, okay, here's my divider, and what is 3 into the third divided by 1n? Well, 3 divided by 1 is 3. And then I have to drop the power down because when you divide, you really subtract the power. So 3 minus 1, even though it's not written, it's a 1, ultimately gives you 2. So we talked about how we distribute here. We're going to distribute these values together. 3n squared times n, 3 into the third. 3n squared times -9, that's really a -27, but because you're subtracting from the next line, it'll change that value. Okay, so whenever I end up adding there, I'm going to end up getting something like a -2n squared. Let's drop that 11 down and then divide again and just kind of keep that process going. So I would challenge you to really try that independently and then kind of check back on my work to kind of see if it makes sense with what we got. I'll kind of move this stuff out of the way because if you remember in class, I'm really trying to make sure everybody understands that when you subtract, you're really changing signs, and a lot of students don't make that mistake with the first one. It's more with the second one. For example, I got 3 here. Why'd I get 3 at the end? I thought 66 plus 63 would be 129. Well, remember, you're subtracting, and so if I'm minusing the second one, it's really doing 66 minus 63, which is 3. So those are small mistakes that most students make when they're missing it. So I'll move this down so that if you do pause the video, you can kind of see what all I did. I'll move that stuff out of the way. I'll just delete it. So just really watch for those mistakes because they're common, and don't feel bad if you make them. Just practice and keep seeing if you can get it correct. All right, we talked about general shape. That's something I've really been pushing in this chapter. Based on the highest power, you understand the general shape of it based on it being a quadratic or a cubic or a quartic or a quintic or whatever. And then also that leading coefficient being positive or negative. So this first one, it looks like I'm doing a negative x squared. Well, the fact that it's squared means it goes 2 directions. For this one, it's upside down because it's got a reflection. So it goes down and then up. So the next part is describing the end behavior idea, and what can be difficult about that is understanding the notation. So let's talk a little bit about the notation. So the idea of the notation is trying to get you to think about like when x is more negative. So like as you move more left, that's the idea of this part right here, okay? As x approaches more negative numbers, what happens to the output of the function? Well, this one goes down. And so that's the idea of how you say down, is you say, well, then that f of x, which is what the function's called, it's going towards negative and negative infinity. Okay, so the opposite of that is when x is going right. When you look more right, given x values that are bigger and bigger and bigger, say you plug in 100 or 1,000,000 or 1,000,000,000 or whatever, well, because of that negative in front of x squared, the output is just really, really negative. So the higher number you put in for x, the smaller and smaller the number is because of the idea that it goes down forever. So the next one I'm talking about is negative x to the 5th. This front value right here is really all you need to understand a lot about it. I mean, this tells you the y-intercept. Same thing here. But this part right here is really critical in understanding like the motion of it. So it has 5 directions, and because it's negative, it's kind of reflected, so it's going more down over time. So it's like 1, 2, 3, 4, 5. Okay, so ultimately like it's a negative idea. If it had been positive x squared, real quick, if it had been a positive instead of a negative, then it would have been up, down, up, down, up. Overall going up as a positive. Okay, so anyway, going back to the notation, talking about in behavior. So again, as x approaches smaller and smaller numbers, as you look more left on the graph, you're talking about plugging in negative 10, negative 100, negative 1,000,000, like stuff like that. Well, those negatives are going to cancel with this negative out here, ultimately making your output go higher and higher and higher. So as you plug in really, really small numbers that are going left, overall the output is going up. That's what that notation means. And the opposite is true when you're talking about the right. When x is moving to bigger and bigger numbers, as you look more right of the graph, the output is more down. It goes down for negative infinity. And so that's what we're talking about here when we say f of x approaches negative infinity. All right, so hopefully that's something that we're starting to catch on to, and we'll see how well we do with that on the test. All right, so the last section here is in factored form, understanding, what makes things 0 if it's in factored form. So hopefully what you're kind of looking at with this is I need to set each part equal to 0, but like each part, okay? Each value that I have in parentheses needs to be set equal to 0 and solved for. Now, if you have some experience with this, then you can kind of look and expect something to happen. Like, for example, 5x minus 1, I should only have one answer because the x has a 1 exponent. It's not written, but it's there. So you can add 1 over, divide by 5, you get one solution for that parenthesis set. Now, the ones that are squared, like the green one and the blue one, the green one is good because, well, it's good and bad. First of all, it's good because you're going to have to add 7 over, which means when you get to the very end, you have a real value. Like the square root of 7 is crazy. It's not like an integer or anything. That's what makes it bad. But that square root of 7, that's a real number, and you also have the negative of that too. So if I was graphing this, I would expect 1, 2, 3, 4, 5 total zeros, but I would only see these two because those are the real numbers. Now I could, find the other ones, because when you set this one equal to 0, let me kind of move that circle down out of the way so you can kind of see what happened there. I'm subtracting 3 to the other side, and then you're square rooting a negative 3. And so the square root of 3 is just the square root of 3. That number is crazy, but I need that I with the plus or minus to suggest that it's an imaginary answer, and it's both the positive and the negative of that. Okay. So same thing over here to the right, and I haven't really worked them out. I mean, I kind of put the final answer here because you add 5, divide by 2, square root. That's a real answer. You subtract 5, that makes it negative. You divide by 2, you're square rooting that, it should be imaginary. X squared minus 2, I'm adding 2 over, I'm square rooting it. That's a real number, it's irrational, it's crazy, but it's still a real number. However, when you do the other one, you end up subtracting, which means that you have an imaginary number you're square rooting, and so that one has a similar answer that has I in front of it. Okay, so tomorrow we have one more lesson we'll be using the calculators for, and then we'll be reviewing for the next class period after that, including tomorrow a little bit, and then we'll take our test on Friday. Thank you so much for watching my video, and have a great night.